Well, I wasn't thinking problem, I was just thinking in an attempt to quantify as an engineer.
They did calculate that last semester, the preliminary, but because we did not run the oil, they did not repeat the calculation.
Well, he's saying that we calculated using our experimental data.
Yeah,
Right.
we did not run the oil, so.
I'm surprised you're sticking with laminar mixing just because turbulent mixing is far more effective. Although I did love this the striations figure. And the question I was going to ask during that slide, and forgive me for my indelicacy. You have a 4-to-1 ratio between methoxide and oil. So how are you matching flow rates?
We have a ratio between the two manually controlled flow control valves. It's right now the flow rate for the triglycerides that use vegetable oil is 0.98. And I apologize, this is not English engineering, this is SI units.
It's fine. What's the ratio to the two of them?
And the methoxide is 0.26, so it's about 1 to 4 as well.
Okay.
It's very close to
Yeah.
that.
That is, all right, that's what I was
So that is how we would calibrate the valves as well. Because with the manual valves, you would calibrate them with the diameter of the opening by hand. So yes, I would use the ratio.
I have something to say about that as well. The data acquisition board, actually using the flow meter at the end result, can help you in getting the right flow out, because as the flows change and pressures build up in the system, things can change, and the flow meter will know right away when something has changed, as long as you've input the ratios that you desire into those fields, and it'll help you open or control the valves in the right manner. Like I said though, the ratio between the two valves is still up to the user to make. When I programmed it, I had the one valve being that ratio smaller than the other, so that the ratio between them would be held constant as the flow valves are controlled.
Okay, I think.
Right now, we can't use the computer program to do that. Right now, we have to do it by hand.
Well, I just, my concern was in general, you have a 4-to-1 mass or volume difference, however you want it to ratio. If your flow rates are 1-to-1, you're going to run out of catalyst,
Yeah.
after you've gone through a quarter of your bulk oil.
Yeah.
So, yeah, I was wondering how you were handling that. I think that's kind of it for the engineering. If I could just make a couple general presentation comments. Your dissolve time slide, actually all those slides on mixing temperature, but the dissolve time one you had negative time. So we'll be going backwards in time potentially
Yes.
with this.
No, it just shows up. This is the dissolve time. It showed up on the graphic, but that actually doesn't act.
I understood. Again, it wasn't a serious engineering question. The point is, for presentation purposes, that's really busy with the grid. The font's really small. If I could recommend recommendation for everybody, stand a good 5-6 feet away from your laptop, when you're making these, to get an idea of what it will look like for everybody on the screen. Also, you mentioned, a lot of qualitative language during the course of the presentation. The dissolve time curve fit was really good. Show us an R-squared value.
Okay.
And that way we just, at an R-squared value of 0.95, we lose all the ambiguity for qualitative statement, that kind of thing. But overall, really good job, and I'll hand the microphone off. Thanks.
That's why I was so startled.
Thank you guys. If you guys want to go see, we actually have the reactor outside. You guys can come look at it and touch it. Whatever you guys would like. Thank you.